identification, right? Can you see on the board? Okay. So in the previous we study, các bạn này cứ vô liên tục làm cho cô mất tập trung quá, các bạn cứ request vô lại. Bạn cứ request vô hoài, các bạn nó không có lên đến giờ. Okay, so let me review that. Model identification. So, what is this? In the previous, we tried to define PDQ in our model. So, if we want to define the ARIMA model is the suitable for your data, so we must define PDQ. So, first of all, we set like initials model. So for define initial model here, we must define initial of P, D, Q. And after that, we say P, D, Q until we define the model can explain your time series data. That is the main purpose of model identification. So if you want to do that, so you must remember the stationary, right? Stationary, non-stationary, the difference. So difference thing is the main purpose of difference is the linked and non-stationary. Non-stationary data becomes stationary. So for difference thing here, you have like the first or the second is your data. So until you can find a stationary, but it's not over two. In the previous, we focused on different things. Different thing is just non-seasonal and seasonal. Seasonal. Non-seasonal. So for seasonal, we consider S, ARIMA model, look like that. B, D, Q. S, that's seasonal. For non-seasonal, so just like that. Then, like the previous lesson, so several students asked me about S here. So let me remind you that S here, that is the length of the seasonal. So for example, if your data is monthly, so S will equal 12. If your data that is quarterly, so N equal 4. So it means, for example, S weekly maybe equals 7. So S here, that is the seasonal length. So it's not always it's 12. Okay. So the question is, so in the previous, you remember different here, that is y will be equals yt minus yt minus is. And that is the for non-seasonal. But for seasonal, you have like that. Yt minus yt minus s. Here represent for the first differences. But what about the second differences? If your data need to do the second differences, so how we can do that? So let me share with you how we can do with the second. So you can look at the slide. I'm going to share with you in the slide. The slide we call that is the backshift notation. Backshift notation. Okay, what does it mean? It means that support for you to make the difference in the second level. So for the second level, so you can write like that. Okay. So what is the second level? We want any idea what the second level? Second level here should be that. That's what it is actually is different white tea, right? So we can write like that is different y's square, that is yt's equal to yt's. So if you look at the backshift notation in the slide, you can see that you have the backward shift operation B is defined by B equal to Y equal to YT minus. So if in the two periods, so you can see that is the first periods, then the second two periods. So you have B and B YT. So will be equal what? B square YT. And that will be equal what? YT minus 2. So it's not it's right. Let me do step by step it. You see that YT is here, that is the y's. Different y here, that is equal as well. Right? YT is minus YT. Okay. And so from that one, so you can write like that. YT is minus 2 YT is minus 1 plus with YT minus 2. So you may ask me, so how can I draw from plus 1 become plus 1? Right? Right, everyone. So let me show you that. So if you look at this, it's BYT. So we have a formula like that. Let me quickly and make that is how we can make the different thing in the second level. This is really so. So if you want to understand about like the second level, so let me do what B plus B YT equal to YT minus 1. So, so one thing about that one, I should write it for you. Let me start with this. And just think away how I explain that for you. Easy. YT will be equal with YT minus 1. T plus 1. T minus 1. Okay, that is the first difference. So, YT here, we have, that is, we have one black sheep, that is a given. That's, and so that is we substitute in here at the back sheet. The back sheet YT minus what? You substitute in here, you have BYT minus 1. BYT. So that is will be 1 minus B YT. Okay? Okay, everyone? So next, that is the second. In the second, you have YTs. U will be equal with Y. The first minus the first, right? So this one will be equal with this. We just approve 1 minus B YTs, right? And that's one we can write that minus 1 minus b y t minus 1 is it. So we can rewrite that 1 minus b will be yt minus yt minus 1. So that's one will be equal 1 minus b yt. So I can write like that 1 minus b square yt. Right? So let me write that. From here, I can rewrite that this second y t will be equal to y t minus 2 minus yt minus 2b yt everyone and plus b square t. Right. Let's see. Sorry. Here, that is. Why that is. Minus b. So we can have 1 minus 2b plus b squared yt is this. So if you look at this, so you can see that the way we can find that one, y, the second one. So we can write like that. The second difference. So it should be like this, because that is the general formula. So here in the second, so we can write that is yb yt is b. Okay. So that's why in the second one, so we can have b is equal 1. Hello everyone, can you hear me well? Hello? Hello, hello. Hello everyone. Hello everyone, can you hear me well? Just let me know. Okay, because study online class, so let me check if you can hear me. Okay, that is support for you to find the second one. This is very general. So, for example, here in the second level, but what about in the fourth level? But actually, in the real, in the practical, so we just start in the second. Okay, then we finish with model identification. So the next step after you can define, we review that, define BDQ. What we should do? We move to another that we estimate. Them. So what we should do in the estimate parameter. So you know that for every model we have YTs, regression, right? Regression should be like that. C plus 1 YT minus 1 plus Y P Y T minus P, sorry, yes, Q plus 1 ETs plus 1 minus then Q P minus Q. So after we finish define PDQ right now, the next step we must to estimate the parameter. So we estimate parameter. What is the coefficient of the regression? Okay, we must estimate it. So how can we estimate? We can use the least square. Least square methods to estimate, but actually that is you do by hand. Right now we have like many software to support for us to can estimate them. You put the data here so you can estimate them. So we also can use like the maximize likelihood procedure to estimate. It means that first they also have the initial, so they update that until they can find the suitable, until we can find the parameter here can explain for what it is. But they said that for select the ARIMA model, we need to many experience. It means we need to practice, we need to do with data and run many times so we get the experiment when that is suitable. So that it needs many like technical skill. So that's why I don't mention, I don't want to focus on like maximize likelihood procedure, but I just want to tell you that we can use like many types or can estimate that. Excel is also can, but we need to do many steps before we can. I think Excel is not support for that. So I see that when you the mini tab for they refer to do that. Okay. So let me give you example. Okay. So when you estimate the parameter here, so what we should consider? We should consider the standard error. We should consider S. We should consider T value. So the parameter just significant different from 0. So we keep that in the model. So for example, here you do the hypothesis testing. So we assume that phi1 equal to 0 and Alternative hypothesis is P1 is different with 0. So if you recheck x0, it means P1 equal to 0. A different result. For example, here you have the hypothesis equal to 0. Alternative is different with 0. So if you recheck that, so P1 is different 0, so we keep P1 here in the model, okay? If that is not significant, if you do not recheck, so you must eliminate P1 out of the regression model. You drop them from the model. Okay, so remember that. So let me give you an example. So after we finish the model identification, okay, in the first step, so we have the intensive model, the initial model. So we have the initial model like 101 after we finish the first step, okay, everyone. So that is the tentative. So right now we move to the second step. We have like assume that we have the 100 observation. So we run regression model. So you can have like that. That is C. That is P1. That is how to pronounce that one, everyone. This notation, but it's 0.5. Okay. And the standard errors for corresponding with each of them, I find that is 7.02, 0.7, and 0.21. So the next step, I calculate t value. I consider the standard errors already, so the next step that is p value. So for p value, you take back the standard error, so you divide for P1, that is P1, right, everyone? You get as 1.47. But actually, when you run regression, they also give the output. You can see t value in the output. You don't need to do like calculation like that. You can see in the output, Excel or output of Minitab, and also p value. So in here you calculate t test t value and p value. So p value here that is 0.14. 0.14 is greater than alpha. So that is p value, that is alpha, right? That is p value greater. P value is 0.1. Greater than 0.05, greater than, that I do not recheck everyone. I don't know, here that I do not recheck. Here 0.05. should be recheck. Recheck or do not recheck, everyone? Hello, who can let me know that I recheck or do not recheck? Everyone who can let me know. Please. So here is depend on like if how many alpha p value. So for example, alpha equal to 0.01 is 99%, but usually it's alpha is 0.05. But this should be alpha divided 2, right? Okay, so I left this for you. It rejects. If that is equals 0, rejects, so we keep that. It do not reject, so we drop that out of the bottom. No one answer my question. Okay. So that is we eliminate V1. So if you look at this, everyone, your model is look like this. Have the model. Plus what? 0.5. So right now, that is the V1, right? We delete that. Eliminate them. Eliminate them. So right now, the model, the ARIMA model, the original you have, the ARIMA model like that. 1, 0, 1. 1 here represents 1. R. Here represents for D, right? The difference. And here that is represent for MA. But right now, we drop V1, V1 here, the original that from the auto regression, right? Auto regression. So the model right now become what? 1, 1, 0, 1. We transform that become 0, 0, 1, right? Because we eliminate P1 out of the regression model. So you have the U1. So that is the ARIMA. ARIMA will be equal what? NA, NA1. It's because different thing equals 0. P equals to 0, so we come as model. Everyone, any question until now? Do you have any question, everyone? Still okay? Okay, so no question, so I will continue. This step, we already estimate the coefficient, right? Estimate the coefficient. So we fit that. The model is like this. The next step, that is the model checking. The model checking, that is what we should check. What we should check in the model checking. We check that in the adequacies. So what are the adequacies? So they define that a model is adequate if the residual left over after fixing the model is a symbol or simply why not. So let me give you example later to demonstrate that is what is the garbage checking. And when we model checking in this step, so we should pay on like AFC and PAFCs of procedure. Remember here that is the procedure, not the errors. So suggest how the model can be improved. So, but if you want to check the adequacies, so we use you remember that test, the Postman-Toll test. But I remember I already introduced to you that is this test, right? Non-alternative containment. So when we use that test, here Q represent for the stars, Q stars. So this we use the chi-square distribution. We use chi-square for distribution. Chi-square. And so what is n? Let me write it down. This is estimate. So here we have Q. n minus k is 1, or I can write like this. 4 n minus k. So RK, that is residual autocorrelation at log k. N, that is the number of residual, and number of residual. K, that is the number of last. H, that is the number of time last to be tested. And R, that is the total number of parameter estimate. H minus R, that is the degree of freedom. Okay. So here, when we use that test, so we consider also the p-value. The p-value here that is associated with the Q star. So Q star we can find p-value. If lesser than 0.05, so the model is the inadequacy. Okay. So if you have the inadequacy, what should you do? Your model is not enough, not adequacy. So we must do to make a new model, or we can improve the model, or you can modify, should be modified and make a new. So when we stop until satisfied model determined, until you get p-value here greater than 0.05. Okay. Okay, everyone. Okay, everyone. Các bạn gì Nguyễn Hoàng Anh Tuấn với bạn Vũ Hoài Anh Thư, bạn ấy bị vô nhầm lớp. Bạn ấy vô nhầm lớp đó, nên là các bạn nào quen hai bạn đó thì nói bạn ấy vô cái lớp vô lại cái lớp time series chứ không phải lớp MCD. Phải bạn người khác vô MCD. Bạn nào biết được hai bạn nhìn vô cái nha. Bạn bị vô nhầm. Study the check-in model, the model check-in. So right now we finish with 3 steps, right? The first step we define B, D, Q, and the second step we define the parameter. Parameter is mean the coefficient of the whites. And after that, you check the depth. everyone? So the fourth step that we must be forecast. So forecast here is we already know, so I don't mention in this procedure. So just mentioning 3 procedures here. Everyone, fortunately, right now we have a software. They can support for us to define like chi-square, Q stars, key value, and the parameter. So we don't need to do by hand. But I will think about that how we can check your understanding in the final exam. So I should ask you to calculate or another version. I don't know, but let me think about that. Okay, so let's go with example for model checking. So, for example, the significant spike at the seasonal lag suggests an additional component to the chosen model. Significant spike at the small lag suggests increasing non-seasonal AR or MA component of the model. So here we have a seasonal lag and no seasonal. Right now we need to use like Pomental test, right? Test for receiver. Check the accuracies here. If not, we must modify or make new until p-value greater than 0.05. In here, I mentioned about AICs, AIC value. So actually here, that is one kind of the parameter we need to calculate by the formula, but actually we have the software help us to do that. So I don't want you to focus on this one. But I'm also putting it here. So for you, when you read the books, you can understand. You know about like AICs. Okay. So any question with like model identification, estimate parameter, and model checking? Any question, everyone? If you don't have the question, so I go with the example. So in example here, that is the cover 3 steps over 3 steps. So okay, I want you to spend time to read the problem first, and we can do step by step.
everyone, I upload the Excel file in the platform. Can you see it? So that is the data for this example. If possible, so you can download the Excel file and we can practice on that. But unfortunately, Excel just can support for us to get the regression only. But if you can find, if you want to find like autocorrelation function, we must to do several steps. So in here, I have the websites that is support for us to make like the ARIMA for testing, also the ARIMA procedure, difference identification of estimate. So I copy the link and send it to you. If you refer to your Excel, so you can use this one, or also the Minitab. Because I use the MacBook, so I cannot find the Minitab version support for Mac. So if everyone you will use Windows, so you can download the Minitabs. Here, everyone, I copy the link and I send the chat box. Open it. That is support for Excel. But I think useful. Everyone, can you see it? See the link? Everyone? Hello? Hello? You hear me? You still hear me? Okay, thank you. So if you look at the website, if you look at the Excel file, so in the ICS Corporation, so I already run regression. And in another sheet, I also put another data is for you to practice. Okay, are you finished to read the example? So let me go to explain that. So right now they want to build a ARIMA model, right? So what the data I just given you in the Excel file, so we can draw the plots like this. So look at this plot. So who can let me know that is the stationary and non-stationary? They responding because study online class just only means because it's so boring. Everyone, that is stationary and non-stationary. Look at the sharing slide. Or you can, if you want, so you can practice to run that, to draw the plot, so you can see that. Yeah, that's here that is the stationary, is it? So that is the stationary. The stock price vary about the fixed value approximately 250. So if you look at the 250 here, that is the fluctuates around 250. Okay. The next step. So in this example here, I'm showing you like 3 steps. The first, that is the model identifies. The second, that is the estimate parameter, and final, that is the uh, model checking, and final, that is the forecast. So let's see. With the data like that, so I can draw the autocorrelation function. So for autocorrelation function here, you can see psi and deadline to 0 after like 2, 1, 2, right? Just only 1 and 2. If we look at the partial autocorrelation close to 0 after like 2, is like 1 here, that's 2. So that suggests for you what the figure tell you. Everyone? So they suggest you what kind of model? AR or MA model? And the last K equal 1. So if you want to know that is the AR or MA, so we should to back the slide is not that. It's slide and already share with you. You remember like what is the AR? Drop out, pop up, die out. Remember? So open that slide, please, so you can see that. So if MA, so let me quickly review it for you.
So for MA model, here you see PACF for ACF, that is a cut up, then die out. For MA, then you die out, then cut up. And for miss, then you die out, die out. So if you look at this figure, so who can let me know that is the MA, RA, or miss model? Which one? Everyone, please answer my question. Oh, really? You cannot see slide? So let me share. So I don't know what's wrong. Let me share. Okay? It's okay right now, right? So my question is, if you look at the autocorrelation here, baseline to 0 after class 2,
and here close to 0 after plus 2 for partial autocorrelation. So if you look at this, what the model suggests us, which one we should choose? Everyone who can answer my question? So can you explain that is enough? So can you give me the reason why you choose that is the MA? Phan Thị Kim Ngọc. MA because the model dropped to 0 after second. But you mentioned about the ACF or PACF. So if you look at this, so AR, if you look at model AR, so you can see so here that is the die out after 0. Autocorrelation is die out after 0. And here that is the cutoff after, that is close to 0 after plus 2. So that is should be 2. One is die out, cutoff. Okay. So the last one we can do that is 200. This is D equal to 0, Q equal to 0. So it means we finish in the first step here, we model identifies. We define the model identification. The next estimate. So we estimate that is the output of the Minitab. We estimate what we should consider here. We consider the AR2 is 1.7 E value. But I think we should take a break, and after that we can go back with the estimate. So I think I need a little bit break. Okay, everyone, break, and after that we continue. 10 or 15 minutes for break. Okay, so I will back later. Why can this be missed? So should check the model. You should check the model, the autocorrelation and partial autocorrelation of MA and AR and mixed model. Die out and cut off. Die out is mean 10 to 0 gradually, and the cutoff is mean disappear or 0. So if you look at these figures, so you can see that the first study die out, ACF die out, and TACF at that cutoff. Okay, Manuel. Hello, Manuel. So that's why I choose the AR. So I also have deadline to 0, right? Here that is the close is close to 0 after last 2. That is the cutoff. So we move to the next one, that is the estimate parameter after we define the element, initial element. So for estimate the coefficient, so we can see that x2 here, no, phi2 is not significant. Let us see. T2, T of our 2, T of auto regression 2 equal to 1.75 hertz, corresponding with p value 0.085. So it's like greater than 0.05, right? Everyone, that is greater than 0.05 says. Can you see it? So right now in the second step we consider with the S and T value exists. S is how many? So you have S. So you have the coefficient. So actually you take that's 1. You divide for this one, so you get minus 2.6. For example, you get the T value of AR1 T value. So T value will be equal to 0.1 coefficient divide. So you take, let me see, you check this. Which one divide everyone? Let you take that number, you divide for this number, is how many we can get? Minus 0.3243 divide for 0.246. So that it will be equal to 2.6. Is this everyone? We can check it. Is this everyone? Okay, let me share it again. So here, in the second step, so we divide S and T value. Right now, we consider what AR1 T value. So I want to check that. You can see here. So who can help me to check the divide? So let me get 0.324 2.354.0246. Okay, so you take that number minus 0.3243. You divide for 0.246. So that will be equal minus 2.6. That is t value. So the same for n02. T value we can calculate on this instead. So after we calculate p value, what we should do? Everyone, who can let me know? Everyone. So it's not significant at 5% level, but significant at is the 10 level, a 10% level. So if go back with this one, if we go back with this one. So that is 0. Here we just find that t value here and p value. That is we check or we accept that. So here we greater than. So do not reject 0.1. We just calculate here the p value. So greater than 0.05. So if greater than, so we keep that. Right. So let me see. We do not reject, so we keep that. So right now we stay in this step. So original we have 200, right? 200 right now. So we consider which one should be eliminated, should be deleted. That is p value greater than 1 here. P value here, yes, is 0.08. Thank you.
0.085. So
eliminate or keep back.